Students, today I am going to discuss the topic our first order correction to the wave function. Before the class, we have discussed first order correction to the wave function. First order correction to the wave function. Now we are discussing, later on we have discussed first order correction to the energy, that is En of 1. First order means it is represented by 1, and here first order correction to the wave function is represented with psi n of 1. For this we are taking function wave function psi n of 1 is equals to summation L equals to 1 to infinity Al psi L of 0 order, that is equation 5. Now what we are doing, substituting this equation in the first equation, what we have done in the first order correction to the energy. So in that equation I am substituting and again multiplying it from left by bra of psi m of 0. So this is the equation, first equation we have taken from the first order correction to the energy. H0 psi n of 1 plus H1 psi n of 0, which is equals to En of 0 psi n of 1 plus En of 1 psi n of 0. Here H, we know that H is a Hamiltonian unperturbed, H0 is the Hamiltonian for the unperturbed and H dash is the Hamiltonian for the perturbed system. And here En represents the energy function. Here also for the 0th order, for the first order. And again we need to multiply with this with bra of psi m of 0, and also we need to substitute in the place of psi n of 1 this value. So how we will substitute? First see, instead of this we need to substitute this. So summation L equals to 1 to infinity Al, this one. Instead of this we need to write this one, and psi m of n is the bra vector of psi m of n, H dash as it is, and psi L of L is this one. This whole term in the place of psi n we are substituting, got it, which is equal with plus, and here H dash bra of psi m of 0 and same psi n of 0, which is equals to this term, left right hand sum term, psi n of 0, En of 0, psi n of 1 is again this one. So summation L equals to 1 to infinity Al, this one and this one as it is sum En of 1 and bracket of psi m of multiplying psi m of 0 to psi n of 0. Okay, next one, we know that since here H0 is the Hermitian operator, so we have the condition for the Hermitian operator is bracket of psi m of 0 H0 psi n is equals to, we can write like this, En of 0 summation, so bracket of psi m of 0 psi L of 0. So substituting this one in the above equation means in this equation we need to substitute. So what we will get this term like En of 0 bracket of psi m of 0 psi L of 0, summation L equals to 1 to infinity Al plus bracket of psi m of 0 H dash psi n of 0 is equals to En of 0 bracket of psi m of 0 psi L of 0, summation L equals to 1 to infinity Al plus En of 1 summation bracket of psi m of 0 psi n of 1. Here this step we are just expanding this term. Why? Because here the summation term, so I am expanding this term in this way, like L equals to 1 to infinity. So in this term we can take L equals to 1, so we can also take m term. So in this term we are taking the term am. So am I am writing outside, and En also I am writing En also writing as em, because we are writing only the em terms from this summation one. So similarly this one psi m bracket of psi m, and here also psi m, we are writing the terms of m. So plus again the same term we need to write, just we are expanding with the m here, so all with m, and the remaining term will summation L equals to 1 to infinity Al, and remaining the bracket term this one, same, plus this term remaining term equals to, here same condition is there, L equals to 1 to infinity Al summation. So here also we will expand the summation term, that is En of 0 am bracket of psi m of 0 plus remaining term like summation L equals to 1 to infinity Al psi m of 0 bracket of psi m of 0 and psi L of 0, and remaining the rest of term is same. Okay, Next, then what we can write here, em of 0. Here the normalization condition is there. So normalization condition is psi n of 0 or psi n of bracket of psi n of 0 is equals to 1. So yes, psi m of 0 bracket of psi m of 0 psi m of 0 whose value is equals to 1, and plus this term, this both are different term, so this whole value becomes 0. Al into 0, it's 0, so left out the term, and next plus this term will be there, remaining the term same we have written, which is equals to this one, en of 0 am of 0. This is the normalization one, so this value is 1. These are the opposite one, 0. Here also summation, sorry, bracket of psi m of 0 psi n of 0, this value also becomes 0. So we also left with this term am of 0 plus bracket of psi m of 0 h dash psi n of 0 is equals to same this term. So what I am writing, taking this term to the that side, right hand side, so we will left only the term, so we can take the term am as common. If we take am as common, we can write en of 0 minus am of 0, then we can write am equals to this term by this term, so am equals to m. So here why how we can write, means instead of psi m we can write m, instead of psi n we can write n. So see here psi m place n I am writing, h dash same h dash, n and en same. So here where m can be written as 1 2 3. So next, so from equation 5 what we can write, what is, where is our equation 5? Okay, here equation 5, using this equation we'll write another equation, that in this equation what we will write, psi n of 1, this whole value we got this al value from this one, so here we are writing that value. So writing the value like so writing this equation, the term fifth equation in terms of m, psi n dash is equals to summation m am psi m, summation psi n is equals to m. Am value we got it, that is this one, we got this one, writing this one and substituting here we get this one. This is a what, this is a first order correction to the wave function, this equation 5. Now we can write how the energy and the wave function of first order can be corrected. So energy of the first order is an equals to en of 0 plus en of 1. So en equals to en of 0 en of 0, and en of 1 we have calculated first, that is this one, the previous class we have done. So substituting that, then we get the corrected energy value, en equals to en naught plus n bracket of n h dash n. Okay, and the wave function also same, we can find out psi n equals psi n 0 plus psi n 1. Here we are finding the first order, means corrected first order, total first order. Psi n is first 0 then first one, psi n equals to psi n naught plus psi n, we got it here. So substituting this, so from this we can also find out the first order correction to the wave function. Why we are finding this, here we get the solutions while we are taking a solution for the all problems, then we get the two things, eigenvalue, energy eigen